start this. So I posted I guess I could have pulled that up while I was here. Where's middle? Down here. Final exam review, that's what we'll go through today. So I've got a copy. The point distribution is kind of weird, so I want to talk about that. Yes, chapter 5, 0 points. It's true. And then I've got some Boolean algebra practice, just for fun, but also for practice. And then remember, no class on Monday because you deserve it. Everyone else has canceled a class or two along the way, and we haven't, so we get this freebie. Okay, I can't remember. I just hit record and I still couldn't remember. All right, it's just been that kind of a day. Okay, so first of all, last class today. So sad, but also fun. So first thing I want to do is just talk about the final exam outline, give you an idea of what to expect. Okay, so I'm not committing to the number of questions, but approximately 12, just roughly. But I am committing to the number of points. So it'll be 90 points because it has to be the same across all the sections. And then how we distribute the points, we're allowed to be a little bit different. And so that's why I was saying before, you want to make sure that you go and sit down and write my final exam, because if you write Paul's final exam, it's going to be all logic, and no one wants that. Maybe if you want all logic, then go write Paul's exam. You'll love it.
It's logic and functions. I think it's like 90% exam. That's about it. As long as you have that.
Just all logic. And also, this is from the final exam as it is right now. I'm willing to redistribute these 16 points, although I'm fine keeping it where it is in set theory. Set theory is easy, and I think it's supposed to kind of like boost self-esteem and be kind of a nice, reasonable 16 out of 90 points. That's a good chunk. Right, so I'm happy to keep it there unless you see a different category where you think, oh, we could probably perform better in some other chapter, right? But as it is, what do you guys feel like? 16.
Yeah, that's good.
16.
To whatever question I get wrong, and it's not chapter.
Yeah, so here, we'll keep as is the only feedback I'm getting. It's relatively easy. It was a long time ago, and so that's why I feel like it's a little bit rude to dredge up so much old stuff on the final exam, but at the same time, I think it's kind of approachable and I don't want to say easy, nothing's easy, but easier than some other stuff. Right? 7 points for combinatorics. Combinatorics can be kind of tricky, right? That's oh, and I should be saying this is obviously on test 1. So for review, if you haven't got your test, well, I pawned off your test 1s on you, right? You can use the test 1 questions, but also the practice test 1 and make sure that you can line them up and say, okay, these are all very similar, right? Because what did I do? I've been promising all along. I've been looking at the final exam. And then practice test and the test is all building up for the final exam. So use those to practice for sure. I'll give you a practice final. I just haven't made it yet. And so, of course, and practice test 1. But you can use those as a jumping off point, right? And so I posted solutions. You've got it all. You've got lots of practice. Okay. Combinatorics, right? How many ways can you arrange 5 different kinds of cars in a car lot, that kind of thing, right? And so that's 7 points, unless you want more, but I was good with 7 because it can be quite difficult, and I'm not gonna try to do anything crazy, but it's been a while, so it might feel a little bit hard. So that's why you got to practice. Same thing, test 1, practice test 1. Those are good resources. You have assignments, but I haven't really been looking at the assignments to make sure that they align properly with the test. So I would focus on the test and the practice tests for practice. Okay. And same thing for logic, was also on test 1. It's at 9 points. I guess, riddle me this. Would you prefer to swap these? Maybe do 9 and 7 instead of 7 and 9. These ones, beep, beep. Could do a switcheroo. I'm open to suggestions. I don't know. Because then logic is worth even less. Worth less. No, it's not. It's worth full, but hard. That's my question. Swap them or keep them? Gonna really nail that logic. I'm getting one head nod and everyone else is like,
I think we should swap them. Swap them. But, you know.
Thank you. Logic is the negate the statement. If I study, then I will get a good grade, right? And all those kind of mashups. Kind of tricky. Yeah, so we'll do 9 points for combinatorics and 7 points for logic. I'm fine with that. Exponential and logarithmic functions is not in the textbook, but I snuck it in, right? And you saw it on test 1 still. And what did I do? I looked at the final exam, exponents and logs, and we just did that, right? Those skills. So just make sure you practice those. And also between the practice test 1 and test 1, and then I also gave you an additional page for the exponents and logs. So between those 3, I want you to convince yourself that these are all the same questions, right? Even though they don't feel the same, they're all the same. And then you'll be able to figure out what type of question you have on the final exam, right? It's only 5 points because we only did it briefly, but that's okay. We did do, so chapter 5 is 0 points because I'm not going to test you on matrix algebra. The only time that matrix algebra comes up is implicitly through the adjacency matrix, right? When you have to set up the adjacency matrix. And so here it's tested implicitly through the adjacency matrix. And then we didn't do anything else with it. So there's no explicit question on it. That's why it's 0. because it'll be in here baked into chapter 6 on relations. Relations, that was in test 2 now, right? And so here we've got test 2, we've transitioned test number 2, and of course practice test number 2. Things like, is it symmetric? Is it reflexive? Is it anti-symmetric? What does it mean to be, what's the word? Transitive, thank you. And a proper, is it a proper? The word escapes me. Anyways, I made you do the definition on the test. Anyways, can't remember, it's on test 2 and practice test 2. Right, so that kind of stuff for relations, make the adjacency matrix, right? And that's for 6 points. So nothing crazy, but still. I guess we could do more, but I think, well, I definitely prefer the later part, graphs and trees and stuff like that, so. We moved on to functions, which are a special case of relations, right? And then that's when we looked at things like the inverse of the function, right? And so we talked about inverses, we talked about just what is a function, right? From, if we're going from 1, 2, 3, 4, right? The domain, then every value in the domain has to be mapped from exactly once, right? And that makes a function. And then what are things like one-to-one and onto functions, right? Those special cases. And that's probably good for 9 points. Chapter 8. And of course, this was on test 2 as well. Chapter 8 is recursion and recurrence relations. You just had to do a big one on the test 2. Well, I picked a small one, but where you expand the choose function using the recursive definition of the choose function, n-1 choose k, n-1 choose k-1. You rewrite it out until you get a sum of ones, and then you're done. Right? There were a couple of different examples, but none of them are coming to mind. Oh, telescoping form. I don't think I'll do that though, unless you want it. It's fun though. All right. No takers on the telescoping form. Count how many additions and multiplications you did? No? Don't want to do that? I have one in mind. Then we moved on to graph theory. And so here, this is where, if we want to, we could snag some of these chapter 1 points. So some points from set theory and redistribute over graph theory. So, you know, is it traversable? Is there an Euler circuit? Right? That kind of thing. Same with trees, right? Use, find the minimal spanning tree. Right? That was kind of fun. Take the smallest weight, and then usually find some costs or something. You can think about that. This was it on? Yeah, it was on test 2. Both of those. I kind of lumped them together, but they're 2 separate chapters, but they're both as fun as each other. Then we had that day where I tried to show you change of base stuff, and you showed me how to do it. And so, which was already 10 points. So I was going to keep it there because it seems to be really easy for you guys. Is that true? We didn't really do it, but I know you're really good at it. So, and there was a lot of practice in the notes from that day. So you can use that for practice. And so from the notes, and then I'll give you the practice final, which, like I said, I haven't made yet because our final is not for a long time. But I gotta get on that. It's on the 18th. Yeah. Ways out. But it'll be here before we know it. So I decided might be nice to keep it at 10, unless I hear otherwise. I don't know. Getting nothing. Then 10 points for Boolean algebra, which is what we've been spending the past 2 lectures and the rest of today on. So spent quite a bit of time on it. And so this is things like the DNF and Karnow maps. Oops. Karnow maps. Which again, you can use the notes and the practice final. But lots of questions in the notes, right, from the past, I don't know how many days. Just so it doesn't throw you off, I like to keep this order, kind of the chronological order that we saw things in the exam, unless there's a space issue. Like if I can sneak one on and not waste too much paper or something like that, I'll make little switcheroos, but in general, I like to keep it in the same order that we saw things, okay? So do with that what you will. Any questions about that before we do some Boolean algebra, some more Boolean algebra? Nope, just crickets. All right. Let's see here. So we've got this Boolean function, f of x, y, z, which is the complement of y times z plus y times x. First thing we're going to do is construct the truth table for this function. So where are we going to start? For our truth table, I have 3 variables, right, or 3 literals. So that means I have 2 to the power of 3 different combinations. So I have 8 combinations. So to make my truth table, I have x can be 0, 0, 0. Actually, I'm going to add some lines before I make a real mess. Hey. Oh, it's because I don't. I don't have lines on this page. Okay, that's okay. 1, 1, 1, 1. I'll bump it up just a smidge. Moving on to y. Do the same, but alternate quicker. 0, 0, 1, 1, 0, 0, 1, 1. And then z, 0, 1, right? Alternate even quicker. 0, 1, 0, 1, 0, 1. I always want you to start with the zeros at the top. It doesn't actually matter, but for me, when I'm reading your work, you want to be as nice to me as you can. And so If you want to be nice to me, you start with 0. And if you want to be mean to me, you start at 1, but then I'll know that you're trying to be mean. Which is probably not great. Or some poor soul doesn't watch these videos or anything and starts at 1, and I'll think they're being mean to me. I'll assume. So what do? So now we have all the 8 possible combinations of on-off switches between X, Y, Z. And so now I'm going to slowly compile the complement of Y times Z. But first, because I have to go nice and slow, I'm going to do the complement of Y in one column, and then the complement of Y times Z in another column. You're welcome to do it in one, but I would get so confused, because what would you have to do? You'd have to swap that one to a 1 and then multiply it by this, right? Because that's the and is multiplication. And I just can't do that in my head, but I can make a column where I switch the Y's and then do it. So 1, 1, 0, 0, 1, 1, 0, 0. Now I can do it. Y bar Z, complement of YZ. Now I'm looking across here. The order in the multiplication doesn't matter, right? But I'll read it from right to left just to match. And so I've got 1 times 0 is 0. 1 times 1 is 1. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 is 1. 0 times 0 is 0. And 0 times 1 is 0. Oh, and what's the... So the next column is Y and X. So Y and X is the same as X and Y. I'm just going to read them in the opposite order. And I'm going to do that before I add them up. So I've got Y, X. Okay. 0 times 0 is 0. 0 times 0 is 0. 1 times 0 is 0. 1 times 0 is 0. 0 times 1 is 0. 0 times 1 is 0. 1 times 1 is 1, and 1 times 1 is 1. Phew. So now I can construct the function, the complement of YZ plus YX, where I take these last two columns and I add them up. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 0 is 1. 0 plus 0 is 0. Whoa, I think I said 1, but I wrote 0, so that's a good sign. And now I've lost my place. Ding, ding, ding. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 1 is 1, and 0 plus 1 is 1. This is the truth table for this function, right? It's true if X is off, Y is off, and Z is on. It's true if X is on, Y is off, and Z is on, and so on and so forth. All right, so what have we done? We found the DNF, the disjunctive normal form, right? And so because these are indicating the fundamental conjunctions that make this function true, and so in the next part, find the disjunctive normal form. Okay. Because I have the truth table, we could use the truth table first, and then I'll also show you, if you didn't have the truth table, I like to write out the function, right, in expanded form, and then get the same answer. Okay, so here this is, how do I find the DNF? We could use the truth table. Oops. All right. We could write out what this line is. Now I'm going to highlight it so that I can see all the ones where the function is true. And then over here on the right, I'm going to write out the combinations. So X is off, Y is off, Z is on. X is on, Y is off, Z is on. X is on, Y is on, Z is off. And all of them on. If I add these all up, that's my disjunctive normal form. You're more than welcome to go the truth table route if you want to. On the final exam, it'll just say, find the disjunctive normal form. Okay, so if you want to use this way, that's totally fine. And this means that f of x, y, z is not x, not y, z plus x, not y, z plus x, y, not z plus x, y, z. Alternatively, so if you're happy with solving it that way, then you can stop listening for a little bit, right? But if you want to have another way of solving it, we could say, okay, I've got, let's see here, f of x, y, z. I'll write out the original, not y, z, plus, and I'm going to write x, y, because when we expand this, we want to have them in alphabetical order. Okay, so here, notice I changed the order to be alphabetical. Because then what can we do? Or what do we do? I've got a blank spot for x, y bar z, plus I have x and I have y and I need a z to fill that space. What was our go-to move? We multiply by 1, right? And on your formula sheet, and if you want a spare formula sheet, I've got them here. Then what do we do here? The complement of x plus x, right? If x is 0, the complement is 1. 1 plus 0 is 1, right? So I'm multiplying by 1. Or if x is, what did I say initially? It doesn't matter. The opposite, 1, then the complement is 0. 0 plus 1 is still 1. So I'm multiplying by 1, which doesn't alter anything. And then I can use the distributive properties of these functions. And so here I need to have an x, and here I needed to have a z, right? I need all 3 literals to show up in each of these multiplications. And so I do the same thing. I multiply by a convenient value of 1, which is taking the shape of a z in this case. And then I'm going to distribute this out. So I get not x, not y, z, plus x, not y, z, plus x, y, not z, plus x, y, z. It even is in the same, the terms are even in the same order. That's nice. Same right? Same, same, same. So you get the same thing. I just find that this is a little bit easier to do for me than the truth table, right? Because I have to go so slow in mine. Maybe you're fast, I don't know. Although I wouldn't recommend going fast in your truth tables. You can make a real mess. And so here, notice, so many notice, this is the same as what we found in the truth table. Ah. Ah. Nice. Any questions about the disjunctive normal form? We'll have to do it on the final exam.
Just to make sure, like on the, for number A,
Mm-hmm.
why do we choose like those rows? Just because they have more ones?
Just because they ended up in ones. So we were mapping this, right? The complement of yz plus yx. So we were building up to that. And so that's what's here. So if it's one, so if it's true, then it's true at these combinations,
Oh,
right? Mapping back to the original combination of x, y, z.
I was gonna say like the highlighted ones.
Yeah, these ones,
Yeah.
it's because they have the one here.
Oh, okay.
Yeah. So I only highlighted the ones with ones in the final column.
Oh, okay. That makes sense.
Yeah. Nice. Okay. Good. A Boolean function f has the following sum of minterms representation. That's what we talked about last day. And we've got 4 variables, w, x, y, z, or literals. And first we're going to construct a Karnow map for f. So I'll show you how brief you can be, and then I'll add to it just to kind of get us there. But in terms of how brief you could be, well, you start with your map. And I think I'll give you these coordinates, right? Just so that you know where I want the literals, because it doesn't really matter where you put them, but it matters to me because I'm reading your work, right? And so I'll force you to have some order, but I've also already promised that the final exam only has 3 literals, right? So that's nice. So it's a little bit simpler, but we can handle 4. But I've already made a promise. Starting at 0, 0, we're only allowed to change one of the switches at a time in each move. So 0, 0, 0, 1, 1, 1, which is kind of weird. And then 1, 0. And this is from last day. Same combination down here, 0, 0, 0, 1, 1, 1, 1, 0. Okay. So I want to see all of this on there, right? I'll give you these corners here, but I want to see what values you have here, right? Because that shows me that you recognize that you can only change one of the switches in each move, right? And so, but from there, what you can do, what you're allowed to do is just go straight from these and mapping them as ones on the map. Okay, you're allowed to do that. And so I'll show you what I mean by that. And I'm looking for 5 as my smallest minterm. And so starting here at 0, 0, 1, and then remember it does that jump 2, 3, okay, still no go, 4, 5, okay, good. I want 6, and that's another one of those jumps, right? 6. Oops, tried to write 6. I don't have a 7, 8, remember, has to jump all the way down to the bottom because it also does that jump. I do have an 8 and 9, nope. 10 is over in the right-hand corner, nope. But I do have an 11. And then 12 starts here in the third row, 12, and then I have 13, 14. It doesn't really matter as long as you have 14 and 15, but 14's over here in the right-hand column, and then 15 finally there. You're allowed to do that, right? What else could you do if you wanted to? I'm going to make a copy over here. Just make it a little bit smaller. So here, this is 0, 1, 2, 3, 4. And what's it doing though? It's taking this binary, right? 0, 0, 0, 0 is 0. 0, 0, 0, 1 is 1. 0, 0, 1, 1 is 3, right? And so on and so forth. 1, 0 is 2, that hence the jump, right? So you don't need to remember it if you're really good at binary. 5, 6, 7, 8 down here, 9, 10 over to the right, 11, 12, 13, 14, 15. Right? Paying attention to this switcheroo and this switcheroo. If you're just going by memory, yeah.
I forgot, why do we put the 8, 9, 11, 10 at the bottom row and then like?
Well, it's because we can only change. So from here, from 0, 0, we're allowed to only flip one switch at a time. And so then we switch the second one. But then to move from here, if I went from 1 to 0, I'd have to switch W on and X off, and I'm not allowed to do that. So then I have to go to 1, 1, which is 3, or some version of that, right? And so that's why we've got the switch or the change. So you can map these, but I'm not going to do it for marks, right? This is all you need to show for marks. This is all you need to show. For marks. Right, and this is optional. It's really just to explain what happened. I'm going to make a copy of the map. Now you probably have a nice looking map already, so you could just use that. But since I'm on my iPad, I'll just make a copy of the original. What's our goal? We have to move in groups of 2 to the power of something, right? So that's 1s, 2s, 4s, 8s, and that would be, or I guess we could go to 16, but that'd be the entire map. And that's boring. And you want to start by making as big of a group as possible. Now, what we're going to find in this case is that big group, we're going to cut it at the end, right? But let's just use that as a good place to start and say, okay, I'm going to make this big group because it's obvious, right? How do I summarize this group? This group, W is always on, and X is always on across all these circled values. So this would be W on, X on. Here, y is off, y is off, y is on, y is on. So y can't make up its mind, so it's not part of the group. Same thing with z. Z is off, z is on, it's off, right? So it doesn't make the group. How about, what's another color I can use here? So now, trying to make as large a group as you can still. You're allowed to overlap the groups. And so here, whoops, there's a group. Remember the table or the map, it cycles both left to right, but also up and down. So if you can kind of do something sneaky with that, go for it. But I don't see anything because there's nothing here that I can attach some group to. And yeah, nothing here. Okay, how do I summarize this group? W is on for both of them. So that's good. X can't make up its mind, so it's not in there. And Y is off and Z is off for both of these. And so Y is off, Z is off. We're going to do the same thing for each of these here. Moving one to the right, I'm going to look at W. Well, W's off, W's on. Nope. It's not a good summary. X is on in both cases, so I'm going to use X. And in both of these cases, right, Y is off and Z is on. Then, moving on, same idea. W is on for both of these. X can't make up its mind, but Y is on and Z is on for both of these. Then for the final grouping, W can't make up its mind, but X is on. And for both of these, Y is on and X is off. Or sorry, Z is off. We had to make these smaller groupings, right? To capture those singles. You don't want to be writing them as singles if you can make them into groups of 2 or 4 or whatever, right? And so here, what we're going to note is that we now see that WX is redundant since the other groupings, right, overlap this entire group. Since the other groupings overlap this entire group. Which means we're not going to include it in our simplification. And maybe I'll bump this up here. I'll move that, move this back down here. And just extend my arrow. Whee! Because I want f of w, x, y, z. I'm going to write out the sum of these fundamental conjunctions. W, y bar, z bar. Yes, I'm being lazy. Plus, put the plus here. X, y bar, z plus w, y, z plus x, y, z bar. You want to make sure that you haven't listed the same thing twice. Now we can tell that that's not possible, right? Because these are all disjoint, right? But in general, whenever you're writing out the simplification, you want to remove any duplicates. Any questions about that one?
So we never mentioned the redundant one, WF.
No, we don't include it here.
Okay.
Yeah, once you've determined that, oh, I actually don't need that one, then it's not part of it anymore. Okay. How about you take a moment to practice finding the disjunctive normal form? What do you have to do? Multiply by convenient values of 1, right? To fill the spots, you want to have them in order X, Y, Z for each of these. Try it. Get back to me. And then I feel like we only have one more. That's all right. It's plenty. Yes, you've got it. Just make a note here. I always start with something like that so that I can see where my convenient values of 1 are going to go. This one's tricky, right? That last one, you want to do it piecewise. So you want to expand the y's first, treating not z and z or plus z as one thing, and then you'll have to expand it later. So here, I'll do it in pink maybe, because it's tricky. Just like we did in class, but it was like last week. I think I'll need another page. I am being lazy here because I expanded this here, but then I also expanded it here without writing out the initial part. So I'm going to copy and paste this and clean it up a little bit on the next page. Because I'll say this is Emily being lazy. Because I didn't feel like writing it out, the whole thing again. But we should have, right? So now, what do I have? This is gone. There, that's what I should have written. Instead of just tacking it on. That was lazy. So this is it, but there are duplicates probably, it's huge. And so now we want to eliminate any duplicates. So now eliminate duplicates. And I'm going to copy this, make it all the same color. I like to work methodically, surprise. And so I look at all my complements of x's, and then I look for any combinations of y not z. And so not x here, nope. Nope. Kind of the flip-flop, nope. Okay, so this one can stay. Then I move on to the next one. Again, the complement of x followed by yz. The complement of x shows up here, but it doesn't apply. Not y, not z, nope. So that one can also stay. Moving on to the next one. X, not y, z. X, nope. X, not y, z, haha. Do it in red. Let's keep going because I see another one. X, not y, not z. Okay, close, but no cigar. X, not y, z. Again. And then I'm good. So these had duplicates. This one had duplicates. Once I eliminate those, then I'm good. I have to keep one, obviously. You want to keep one. It showed up 3 times. But but then you can remove the redundant too. Moving on to XYZ. XYZ, not here, not here, not here, here. So again, there were duplicates here, which I'm gonna eliminate. Not X, not Y, Z, not either of these, right? I only have to check these two now. So this one's fine. X, not Y, not Z, doesn't look like X, Y, not Z. So I think that the rest are good. 1, 2, 3, 4, 5, 6, 7. I'm only counting because I did it earlier and I want to make sure I get the same number of terms at least. Make sure I'm on the right track. So then the disjunctive normal form f of x, y, z is going to be not x, y, not z plus not x, y, z plus x, not y, z plus x, y, z plus x, not y, z. Oh, sorry, not x, not y, not z, or z, blah, 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 plus x, not y, not z plus x, y, not z. And make sure there's 7 again. 1, 2, 3, 4, 5, 6, 7. Okay. Say therefore the DNF, just as a reminder of what we were doing, the disjunctive normal form of f of x, y, z is this. Bless you.
Thank you.
You can practice setting this up with a truth table. You would get the same answer, right? And then see which way you prefer, right? The question is just going to say, find the DNF, just like this. I prefer to do it this way. You can use a truth table and you would find the same answer. That's fine by me. Okay. Any questions about that one? Were you ready for your last problem? Well, besides the final exam, I guess. I'm going to put it on this page just so it's not so long. Use a Karnow map to simplify the Boolean function. Now, again, we've got 4 just for practice. Let's see here. Set up the table or the map, I guess. W, X, Y, Z. My combinations are going to go 0, 0, 0, 1, 1, 1, 1, 0. Same across the top. 0, 0, 0, 1. 1, 1, 1, 0. Just for practice, right? So writing this out is optional. So orange is optional. But what could you do? You could write out all the labels and then circle them. That's fine. So 0, 1, 2, 3, 4, 5, 6, 7, right? Making sure you do the move. Right, notice here, here. From 7, you go down to the bottom to 8, 9, 10, 11, 12, 13, 14, 15, right? In the same situation. I guess it's like this, then there. From here to there. from there to there, to there, to there, to there, to there, to there. I'm going to make a copy that doesn't have a bunch of lines on it. Paste. Or maybe I'll scrunch this. Wait, whoops. Scrunch this up. That's better. This bigger. And I'll remove all this. Because I'm just going to go from these values and map ones where I want them. So 4 is here, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Just counting 1, 2, 3, 4, 5, 6, 7, 8. Make sure I didn't miss any. 1, 2, 3, 4, 5, 6, 7, 8. Looks good. This one doesn't simplify very much, right? But you want to make sure you want to look for kind of cycles up and down as well in your map as left to right. Look for cycles left to right and up and down. Yeah. The best I could come up with is some version of this and this and this. And then the same thing in the others, because I can't cycle through, but you always still want to make as big of a group as you can, even with overlap. So if we number these, 1, 2, 3, I'll do 4, 5, and 6, right? 6 is that sneaky one that goes and loops around, right? But we could have just as well written 1, 0, making one change would be 0, 0. That's an option, so I could put that here. Right, I could have written the table, so that's what cycles through. And when we draw this, or when we map, when, just making more room here. When we figure out what these combinations are, I'll refer to the numbers 1. So let's do that one first. Yeah.
I was gonna say, for groups 1 and 3, could you make them as like 1 or no?
No, because it has to be 2 to the power of something size. And so our options are 1, 2, 4, 8. It's going to be hard making a group of 8. But what a simplification it would be, huh? So here, for all of group 1, 0, we've got 0, 1, so W is off and X is on, so that's good. W is off and X is on. And now we're looking at in the row or in the columns, Y is off in both of these, and Z can't make up its mind, so it's not invited. Doing the same thing for 2. W is off and then it's on, so it's not in the group. X is on for both of these, so that's nice. And for both of these, because they're stacked on top of each other, right? Y is off and Z is on. Do them like this. For 3, same deal as 1, similar at least. W is off, X is on for both of these, so that's a good place to start. W is off, X is on. And for 3, Y is off, Y is on, so it's out, and Z is on for both of them. Moving on to group 4, same deal, right? Same methodology, right? W is on, X is off for both of these. So W is on, X is off. And now I'm going to focus on Y and Z. Y is on, nice. Z is on, Z is off. So Y is on is in the group, or summarizes the group. Group 5. Starting with my W's. W's on consistently, so that's a good one. X is on and then off, so it's out. And for both of these, Y is on and Z is off. And finally for 6, which can be a little bit tricky to look at, I guess. But for both of them, W is on and X is off. So W is on, X is off. And across the columns, Y is on and then Y is off, so it's out. Z is off and Z is off. So Z is off. Therefore, F of W, X, Y, Z. Oh, and I forgot to mention, but there was so I fixed it in these notes, I guess, but I had X, Y, Z, W, and I didn't like that because I want to always use the same order. So I did a little scratch and old school copy job on you guys, but just read it as W, X, Y, Z. I forgot that. The simplification is all these terms written out together, W, X, Y bar. Not like that. I didn't say what I wrote, sorry. So I'm not even gonna try until the last one, just for a grand finale. Plus W on, X off, Z off. You did it. The end. Oops, that doesn't say end. Woo. You did it. That's it. That's all you need to know. Just that. This the looks weird. How about like this? Yeah. Anyways, you get the idea. And with that, I release you. And I'll stop this recording. Oh yeah. Oh, looks like the chat was going off. Uh-oh. Oh, we still did stuff, Jace. I still made you do stuff. Let's see here. Oh, nice. Yeah. Okay, I'm all up to speed. I can't see it when I'm in sharing mode, I guess. I don't know. All right. I'll hang out if there's any questions, but I will stop this.